Hi class, in this video we're completing our Standard 16 study guide on coordinate geometry. First question says, which equation represents a circle centered at -3, 8 with a radius of 7? The key here is that we have to switch signs on the center, and we have to square the radius. So that's why our answer is B, because we switch signs. The -3 becomes +3. The +8 becomes -8, and squaring 7 becomes 49. In the second equation, we're looking to come up with an equation for this circle. So the center is at coordinates 3, 2, and counting the radius is 1, 2, 3, 4. So finding the equation that has center 3, 2, we have to switch signs. So that's why it would be D here with radius 4. 4 times 4 is 16. The third question, which of the following is not a perfect square? In order for it to be a perfect square, you could take the middle number, the B number, and it's half of B multiplied by itself has got to be C. So in this first problem, if I take that B value, that middle value, -2, half of -2 is -1. -1 times -1 is +1 and not 4. So that says that the answer is A, that first one is not a perfect square. Compared to the second one, where half of 8 is 4 and 4 times 4 is 16. So that works, and so forth. Next one, determine the center and radius of the given circles. Okay, so we have to switch signs. So our center is at -4 and 2, and our radius is at that square root of that value, so that's 3. For the next one, our center is at +7, and that y squared's by itself, so +7, 0, and the radius is at the square root of 64, which is 8. Next one, determining the equation of the circle, we would have x squared plus y minus 6, switching signs, is equal to that radius squared, so that's 4. The next one, switching signs, will have x plus 2 squared plus y plus 1 squared is equal to that radius squared, so 8 squared is 64. In this problem, we have to complete the square in order to find the center and radius of the circle. So if we first order the problem, we'll have x squared plus 2x. I'll leave room for a blank. And then for the y's, we'll have y squared, so plus y squared minus 6y plus room for that blank. And that's going to equal taking that -6 there and adding 6 to both sides. So when we complete the square here, half of B, half of 2 is 1, and then 1 times 1 is 1. So that number there is 1. And then we're going to add 1 to that other side. Then for the blue problem, half of -3, half of -6 is -3, and -3 times itself is 9, so a 9 goes there and there. So on this side of the equation we'll have 16. On the other side of the equation, these complete as half of B, so the red problem becomes x plus 1 squared plus y minus 3 squared, that's half of B, is 16. So the center is at, switching signs, -1, +3, and the radius is at the square root of 16, which is 4. Doing another problem, we'll first organize our problem. So x squared plus 16x plus the blank plus the y values, so y squared minus 10y plus the blank is going to equal to the constant, so add 11 on both sides. Okay, then figuring out what number goes there. Half of 16 is 8. 8 times 8 is 64, so add 64 to both sides. Then Half of negative 10 is negative 5 times itself is 25. So add 25 to both sides. On the right side of the equation, we get 100. On the left side, we'll get x plus half of b, so x plus 8 squared, plus parenthesis y minus 5 squared, that's half of b, is 100. The center is at negative 8, 5 switching signs, and the radius is at 10 square rooting. The next ones, we're determining the slope of the line, where slope is change in y over change in x. Okay, so the change in y's go from negative 3 to 5. So negative 3 to 5 increases by 8. Then the change in x's go from 4 to 7. So going from 4 to 7 increases by 3. Therefore, the slope is 8/3. In the next problem, the slope is again change in y compared with change in x. So the y goes from 4 to 4, so that's 0. The x goes from negative 2 to 5. So from negative 2 to 5 increases by 7, but 0 divided by 7 is 0, so that slope is 0. For number 8, the midpoint is the middle point, which is the average of the coordinates. So the average of the x coordinates. So the x value will be 5 plus 2 divided by 2, and averaging that out, you get 3.5. The y value will be averaging the y coordinates. So that's negative 3 plus negative 7 divided by 2, which is negative 10 divided by 2, which is negative 5. So the midpoint is at 3.5 and negative 5. So point there, 3.5 and negative 5. Doing the next one, the x values averaging out 7 and 11, the middle number, that x value middle number is 9. 9 is in the middle. For the y value, I'll calculate that out, negative 1 plus negative 4 divided by 2. That's negative 5 divided by 2, which is negative 2.5. So the midpoint is at 9 and negative 2.5. That's the middle value between these 2 points. Next ones, we're determining the distance. So distance is the Pythagorean theorem. That diagonal distance, d squared. The distance squared is the change in x squared plus the change in y squared. So figuring that out, distance squared, the change in x goes from 3 to negative 1. So that changes by 4. So whether it goes up or down, it doesn't matter for the distance. Then the change in y values go from 6 to 9, so that changes by 3. So the distance squared is 16 plus 9, which is 25. Square rooted, that distance is 5. Drawing that out on a triangle, we'd have that the change in x's is from 3 to negative 1, so that's 4. The change in y's is from 6 to 9, so that's 3. And we're finding that x distance, which is 5, because it's a 3, 4, 5 triangle. So the distance between the points is 5. Doing this problem, the distance squared is the change in x squared plus the change in y squared. So that's Pythagorean theorem. Drawing out a triangle at the same time. The change in x goes from negative 2 to negative 6. So that changes by 4. The y values go from negative 3 to 4, which is actually a change of 7. So figuring this out, we'll have distance squared is change in x squared plus change in y squared. So that'll be 16 plus 49. Which is 65. So the distance is going to equal the square root of 65, which equals a distance of 8.1. That's that diagonal distance between the points is 8.1. In the next problem, we're given the endpoints of the diameter, and we're looking for an equation of the circle. So the first thing we want to do is graph those 2 points. So graphing those points, -7, 2, and -1, 2, what I can see, first of all, is that the center of that circle, so the circle will be just a rough drawing right there. There's our circle. So the center of the circle would have to be the midpoint of A and B. That midpoint is going to be, and I could just visually draw that in there, at -4, 2. So -4, 2 is the midpoint of A and B. That's the average of those 2 points. The radius, I could just count that radius to be a radius of 3. So with that information, center -4, 2 and radius 3, my equation is going to be switching signs, x plus 4 squared plus y minus 2 squared equals 9. Next one, we're finding the missing coordinates of the shape. So the first is a square, ABCD. So I could plot those points. And in plotting them, I could see that the fourth point of the square would have to be at 0, 2. For the next problem, plotting those 3 points of the parallelogram, I can see that my fourth point, so this one has a slope right there, and since parallelograms have the same slope, here's the slope of -2, here's my fourth point. So when I connect that, I see that I have that parallelogram right there. So that fourth point is at coordinates -6 and 3. And finally, for the rectangle, I see that I have a slope here that goes up 1 and over 2. So then on the other side, I'll have to go down 1 and left 2 to that point right there in order to make the rectangle. So that has coordinates of 5 and -1. For the next problem, we're determining the most specific name for the quadrilateral with the vertices ABCD, so first I will graph them. Now that we've graphed out the points, let's find the slopes. The concept is that if the slopes of adjacent sides are opposite reciprocals, then those adjacent sides are perpendicular, so finding the slopes. Okay, so for the first section right here, that slope is going to be up 3 over 1. Slope is rise over run. So that first slope is 3 over 1. The second slope is going to be down 2 over 6, which reduces to -1/3. Once I get those two, then I can recognize that that opposite slopes are the same, that this is up 3 over 1, so this goes a little faster. This slope will be 3 over 1, and my fourth side slope is down 2 over 6 again, so that's a slope of -1/3. So now when I look at those slopes, I have 3 over 1, -1 over 3. So those are reciprocals, and one of them's negative. Therefore, we have that right angle right there. Again, -1/3 compared to 3 over 1 on CD, we have a right angle. 3 over 1 compared to -1/3 is a right angle. And -1/3 compared to 3 over 1 is a right angle. Okay, so ABCD is a rectangle because adjacent sides have opposite reciprocal slopes, making the adjacent sides perpendicular. Notice I'm trying to be as precise as I can. What sides have opposite reciprocal slopes? The adjacent sides have the opposite reciprocal slopes. Opposite reciprocal slopes allow us to have those perpendiculars. Finally, for the last problem, we're finding the perimeter and area of this triangle. Okay, so first we can put that triangle in a box. And count those sides. So the sides would be 5 by 3, then it's 4 by 3, and 2 by 7. Okay, so I could do the Pythagorean theorem 3 separate times here. For the first time, it would be 5 squared plus 3 squared is equal to x squared. So that would be 25 plus 9 is 34. And when we square root that, that diagonal distance would equal 5.8. That first distance is 5.8. For the second distance, we have 3 and 4, so it's a 3, 4, 5 right triangle, so that next distance is 5. Then for the last section, that diagonal distance is 2 squared plus 7 squared is x squared, so that'll be 4 plus 49, which is 53. So square root of 53 is that distance, which is approximately 7.3. So 7.3 is about that distance. So if I add those up, then the perimeter altogether will be, adding those up, 18.1. Then for finding the area, one strategy to find the area is that it's the area of the rectangle. Take away the 3 right triangles that are in green right there. Okay, so the area of the rectangle, the whole rectangle is 5 by 7. So that's 5 times 7, which is 35. Then the 3 right triangles, one's 5 by 3, so that has an area of 5 times 3 is 15, divided by 2 is 7.5. The second has an area of 4 times 3 is 12, divided by 2 is 6. The last has an area of 7 times 2 is 14. 14 divided by 2 is 7. So all 3 triangles are 7.5. 6 and 7 added up, which is 20.5. So it's 35, take away 20.5, and that equals 14.5 squares for your area. So the perimeter is 18.1 lengths, and the area is 14.5 squares.